All right, we're going to take a look at neutralization reactions now. If you'll remember back to our reactions unit, you can remember that a neutralization reaction is just a very fancy way of saying a double replacement reaction for acids and bases. Okay, that's all that a neutralization reaction is. When these react, you're going to form an ionic salt. You're also going to form water. Okay, now this ionic salt may or may not be soluble. It may be a solid. It may be a aqueous solution. We're just going to take a look and see some different situations here. So let me get rid of this real quick. And let's take a look at calcium hydroxide, which is CaOH2, and phosphoric acid, H3PO4. Now, I didn't leave myself much room here, but both of these are aqueous, okay? These are both aqueous solutions. So let's go ahead and add in our state symbols here. So what's going to happen here is that a double replacement reaction is going to occur, and my calcium is going to switch places with water. Well, if you notice, your hydrogen is going to be paired up with hydroxide. Hydrogen hydroxide is water. Okay, so there's one of our products, HOH, which is water, which is a liquid. And my other one is going to be calcium phosphate, which the formula for a calcium phosphate would be Ca3PO4. Now, if we look back at our solubility rules, I know that there's not a rule for phosphates, there's not a rule for calcium, so that falls into that bottom rule of all other monatomic and polyatomic ions are insoluble, except, and there's not an exception here, okay? So that means that this is going to form a precipitate, which is a solid. So now we just need to worry about balancing. So if we remember back to our balancing rules, we're going to look at our metals first. So I've got 3 calciums here and 1 here, so let's give this a 3. Let's look at phosphates next. I've got 1 here and 2 here, so let's do a 2 right there. We'll look at hydroxides next. 3 times 2 is 6. And so if I put a 6 here for these hydroxides, 6 hydroxides is what I have here and here. And so now I have 6 hydrogens and 6 hydrogens. So we're actually good on that particular problem. I really don't even know that we need to do another one of these. It's just, I mean, these are super basic. If you remember how to do a double replacement reaction from the reactions unit, then you should be good to go on this. Since this is such a short video, I am going to go ahead and take a look at acid rain in this same video. So let's go ahead and scroll to the very bottom of the notes. I'm going to get rid of this writing real quick. We're going to scroll down to the bottom of the notes, and here we are at acid rain. So let's take a look at acid rain. It says that this is a broad term to show that nitric acid and sulfuric acid falls back to the earth after it mixes up with precipitation. Okay, you're probably wondering, how does acid get into the rain to begin with? When we burn fossil fuels, either in factories or automobiles, okay, those are the 2 places that we burn most of our fossil fuels. When we burn fossil fuels, some of the byproducts of those are acids, and so those acids will go up into the air. Those will mix with our rain and with our snow and sleet and hail and all that fun stuff, and come back down to the earth in the form of a lower pH precipitation, which is what we would call acid rain. It affects plant life, it affects animal life, especially aquatic life, because it's lowering the pH of lakes and ponds and things like that. It can also cause cracks and discolorations in buildings and statues and all that fun stuff. So that's just a little blip about acid rain. Make sure that you're familiar with this for a test or for a quiz, and that is going to do it. Thanks.